Okay, so welcome back to the Straight Edge Tutorials channel. Thank you for tuning up for your solutions. Over here we have a question that is asking us to prove by mathematical induction uh, 1 squared plus 2 squared plus 3 squared all the way to n squared, which is equals to n multiplied by n plus 1 multiplied by 2n plus 1, which is divided by 6. This is for all integers where n is equals to 1 or is greater than 1. So the range is starting from 1. So what we do here, we jump on to the next step, which is our first step. It's called the basis step. You have to write this down. You should make sure that you write this down. And you're also supposed to write that we are assuming that it is true when n is equals to 1, since we are starting from 1. Okay, and then you rewrite the whole expression here, which is what I've done here. I rewrote the whole expression. Now I'm substituting n for n with 1. Wherever there is an n, I'm replacing with the 1, since we assumed that it is true. So I took this 1 and I placed it wherever there was a n squared. So over this side there is n squared here, so I put 1 here, and then I put 1 over here, and then 1 over here. 1 plus 1 is 2. I put 1 here. 2 multiplied by 1 is 2 plus 1 is 3. So I multiplied 2 by 3 and then I got 6. And then I multiplied 6 by 1 and then I got 6 as well. 6 divided by 6 is equals to 1. So it is true when n is equals to 1. Okay, then I moved on to the induction step. It's called the induction hypothesis first, where we were assuming that n is equals to k. Why are we saying n is equals to k? Because we don't know the value that comes after 1, because we were just given a range that is beginning from 1. Now we are assuming that we have a number that is after 1, and we are assuming that this number is k. So we take this equation, this whole expression as well, and then wherever there is an n, we are now replacing and putting a k. So here I put a k and then I squared it up, and then I put a k where there was an n, put a k, I put a k, I multiplied, and then now I had overally k multiplied by k plus 1 multiplied by 2k plus 1 divided by 6. And this is what we call the hypothesis of the induction. And then we also must assume that it is true. You should make sure that you highlight that it is true when n is equals to k, right? Yeah. And then from this we move on to the induction step, where since we know that the next, or the number that we assumed is called k, we are now assuming that let's focus on the next number from this assumed number. So we are also assuming that k plus 1 is true. Okay, and you should write it down. Sorry, I didn't write it down. So you should write that we are assuming that k n is equals to k plus 1. So we take this k plus 1 and we place it wherever there is an n. So you rewrite the whole expression as well, and then you replace n with k plus 1. So since here in the induction hypothesis we found that there is a number k squared unknown, and now we are focusing on the next number from that, we should keep that number, and then we are moving next to the next number, which is k plus 1, and then we square it up. Okay, I hope you understand it. This is the number that we assumed, and the next number from that, that's why we are putting a plus 1 here, because it is the next number from this. If it was 9, we are saying 9 plus 1, the next number would be 10. Yeah, okay, so we put k plus 1 wherever there was an n. You see, k plus 1 here, and then k plus 1 here, and then this is where we are now. Now we want to figure out this whole expression to see if it was true overall. Now this is the overall expression that we have. During the induction hypothesis, we noticed that this this portion that I've highlighted to be a was equal to k plus 1 multiplied by 2k plus 1 divided by 6. I'll show you how. Okay, here during the induction hypothesis we said this was equals to this, you see. So now during this induction step we find out that this portion as well, this same portion is the same portion that we find here on the induction hypothesis, you see, and we said it was equal to this portion. So now I'm taking this portion and I'm replacing this portion with this portion. Why am I removing this? Because we want to remain with k's so that we can easily simplify this whole equation. So I'm removing this part and I'm substituting it with its equal, which is this part. Okay, that's where you find this equation. That's where you find this equation now, you see, because I've replaced here. So now we want to solve this entire equation slowly together. Okay, so I'll do it. Okay, I'll just do it right now so that you can understand each and every step as I go about it. So over this side I'm going to multiply this with k. Okay, so we have k squared plus k in brackets multiplied by 2k plus 1 in brackets as well, and we're going to divide all of this by 6. Then we're going to have here k plus 1, which is going to multiply k plus 1. Why? Because it has been squared, so it's the same as k plus 1 multiplied by k plus 1. Then we move on to the next step where we have k plus 1 in brackets multiplying here. If we simplify here, we're going to find k plus 1. So this k plus 1, if this one adds this one as well, we get 2. So in this entire bracket we are left with k plus 2. Okay, I hope I wasn't too fast for you understanding. Okay, so now we have k plus 2 here, and then in this other bracket, if we multiply this 2 with this bracket here, we get 2k plus 2. Okay, and it is inside a bracket, right? It is inside a bracket. Okay, I'll make this a square bracket, and then I'll use parentheses here, and then we have a plus 1, and then we close, and then we divide this whole expression with 6. So this is where we are. Okay, now we're going to simplify this here. So I will rewrite k squared plus k. Okay, and then I'll rewrite 2k plus 1, then I'll divide it by 6, and then here now I'm going to multiply these two brackets together, and what do I get? I get k squared plus k plus k plus 1. Okay, and then I move to the other side of the equal sign, and I'm going to multiply k plus 1 with k plus 2, and what do I get? I get k squared, and I put brackets k squared plus 2k plus k plus 2, then I close my bracket, and then I multiply it with this. If this 2k is multiplied by 1, it becomes 2k plus 2 plus 1. So if we add 2 plus 1, we get 3. So we are left with 2k plus 3. Then we divide this entire expression with a 6. Okay, now it's becoming clearer. And now we come here over this side, and then we solve for this, and what do we get? We get a 2 cubed. Okay, I'll go slow with you because now I was moving too fast. Okay, I'll say k squared multiplied by 2k plus 1. Okay, plus k multiplied by 2k plus 1. Okay, divided by 6. Okay, and then here I solve for k plus k, we get 2k plus 1, and then over this side I also get k squared plus 3k plus 2. Okay, and then I also remain with 2k plus 3, and then I divide by 6. Okay, then I come this side. Now I multiply over this side, and then I get 2k cubed plus k squared plus, if k multiplies 2k, we get 2k squared. If k multiplies 1, we get plus k. Then we divide by 6. Then I also come again and I repeat this k squared plus 2k plus 1. And then if I come over this side now, I want to multiply this with this, so I say 2k multiplied by k squared, this plus 3k plus 2 plus 3, this 3 multiplied by again this whole expression, k squared plus 3k plus plus 2. Okay, and then I divide this whole expression by 6. Okay, so I come back here again, and then I simplify this as well. So I remain with 2k cubed plus 3k squared plus k divided by 6. Okay, then I repeat this one as well, k squared plus 2k plus 1. Now I jump over to the other side of the equal sign, then I multiply to simplify. So I get 2k multiplied by k squared, we get 2 k cubed plus 6k squared plus 4k. 2k multiplied by 2 is 4k. 2k multiplied by 3k plus 6k squared. 2k multiplied by 2k squared is equals to 2k cubed. Okay, plus now this 3 multiplied by 2k, we get 3k squared. Plus we get a plus. 3 multiplied by 3k, we get 9k. Plus we get a plus. 3 multiplied by 2, we get a 6. Then we divide the whole expression by 6. Okay, now from here, what do we do? From here, I want us to remove this 6. So we multiply everything by 6. So if we multiply by 6 here, we get 2k cubed plus 3k squared plus k, and then we divide it by 6 as well, plus 6 multiplied by k squared plus 2k plus 1. Then we divide it by 1, since there is nothing here, and then we skip over to the other side of the equal line, and then we multiply this whole expression by 6 as well, and then we get 2k plus 6k squared plus 4k plus 3k squared plus 9k plus 6. Then we divide it by 6. So if this 6 divides this 6, we get 1. If this 1 divides this 6, we get 6. If this 6 divides this 6, we get 1. So I will rewrite the expression again. We are left with 2k to remove the brackets, 3k squared plus k, plus 6 multiplied by 2k, we get 6 multiplied by k squared, we get 6k squared, plus 6 multiplied by 2k, we get 12k, plus 6 multiplied by 1, we get 6k. Then here we rewrite the expression as well, since it's being multiplied by a 1. Okay, yes. And now we want to simplify this whole expression further to get our answer. It's easy, it's not even hard. So this is what you do. You group the like terms together. Okay, you group the like terms on this side, and then you group the like terms on the other side. So this is, now we want to make sure that this left hand side is going to equal the right hand. We were here, right? Okay, from this stage we want to group the like terms now. So we take this 2 cubed and we write it down, and then we add this 3k squared plus 6k squared, and we get 9k squared. We add this k plus 12k, we get 13k, and we add this 6 over here. We skip on to the other side of the equal sign. We add this 2 cubed, and it's the same as the 2 cubed we have over here. And then we add this 6k squared plus 3k squared, we get 9 squared, which is the same as this 9k squared over here. And then we add this 4k plus 9k, we get 13k, which is the same as this 13k here. And then we also add this 6. So this right hand side is now equal to this left hand side. So we have proven that it is true for n. So it satisfies the question, and we scoop all the marks. So thank you for your time, and make sure that you subscribe to the channel so that we can keep posting these videos to help you with your assignments and your examinations. If you have any solutions that you also need from some trouble questions and problems that you're coming across, make sure that you post them and use the email and the my description that you find in the description on my channel, so that we can furthermore help one another. Thank you so much for tuning in to the Straight Edge tutorials. I hope that you keep blessing the channel as more as it blesses you. Stay blessed.